61B Project Zero Announcements. Hi, I'm Purva Kapshikar.
And I'm Tamara Vilaythong.
And we're excited about our additions to the N-body simulation, also known as Project Zero. We'll first show you an example of what our addition was. We didn't make any changes to our planet class to make it usable for our additions, except we did change its name to Planet Extreme, and made sure that the objects of this class were initialized as such. Some changes were made to N-body Extreme, such as creating a black hole object in our main method of this class. When we updated the locations of the planets in a for loop, we also called a method on the created black hole to check whether the planet that was currently being considered through the for loop was within a certain radius of the black hole.
We passed in the planet as well as the file name of the data files as parameters for the black hole objects for the black hole classes constructor.
This previous display was an example file that showed the 4 inner planets rotating around the Sun. As you can see, we added a black hole. The planets Venus and later Earth were sucked into this black hole, and were no longer part of the system. Because of this, the remaining bodies in the system were no longer influenced by these planets, and when calculating net forces within the system on each body, these 2 planets were no longer taken into consideration.
Here's another example of a black hole with another initial system.
We're no strangers to love. You know the rules, and so do I. I've still commitments while I'm thinking of.
We created a black hole extreme class to create and manipulate black hole objects. This class had instance variables for the x and y positions of the black hole, as well as an instance of the in class to be able to read the text files used in order to give data for the system, such as the radius, positions, and velocities of the bodies in a system. We utilized the radius that was provided in these text files to determine the range that a black hole could fall in, and still be visible on our screen, and potentially in the path of one of these bodies.
We initialized all these values in the constructor of the black hole class. In order to make the position of the black hole random, we used the math.random method as we had previously learned in AP Computer Science, so that we could generate a random x and a random y position that was still within the range of the radius provided in the text file. And we also added a buffer of a few thousand to make it less likely that the black hole would end up at 0, 0, which would make the Sun immediately get sucked up in the black hole and cause all the gravitational forces of all the bodies in the system on each other to immediately deviate from their initial values. We initially only generated these numbers in a positive range, making the black hole only appear in the first quadrant of the display.
To have more variety in location, we realized that we needed to have a variable that could negate the x or y position of the black hole. We once again used the math.random method to mimic a coin flip, and by converting the resulting number into an integer, the 2 possibilities of calling this method was either a 0 or a 1. We then wrote 2 if statements, one for the x position and one for the y position.
If the value of our hypothetical coin was a 0, then the x position that was initially positive would be negated. But if it was a 1, then the x position would remain the same. We had another variable representing a coin flip for the y position, which followed the same pattern. A 0 would mean negating the current y position, while a 1 meant keeping it the same. These 2 coin flip scenarios allowed the black hole to appear in any of the 4 quadrants.
When updating the location of the bodies, a method would be called to check whether the location of the body fell within a certain radius of the black hole. The black hole would also be displayed on the screen. If the body fell within this radius, then another method was called, which would set the location of the body to a very large number, essentially making it disappear from the screen, and its gravitational effects on the other bodies in the system negligible.
That concludes our video. Thanks for watching.